Welcome back to Chemistry Matters and our unit on acids, bases, and solutions. Were you able to use your scientific calculator to calculate the negative logarithm of the molarity of the acid you used in your titration? Let's see if your results were similar to the results obtained by our students.
Who wants to explain how you calculated the pH of the acid you used in your titration lab?
I'll try. We used the data in our notebook from our titration lab. The only thing that we really had to find in our notebook was the molarity of the acid we used.
We used the same acid, hydrochloric, which is 0.1 molar.
So all we had to do was use our scientific calculator to find the negative logarithm of 0.1. The acid was 0.1 molar, and the negative logarithm of 0.1 is 1.
Good. So what do these results mean?
It means it's a very concentrated acid. It has about 10 times more hydrogen ions than lemon juice, which has a pH of about 2.
Well done.
With that calculation and explanation, you now have a deeper understanding of what the numbers on the pH scale indicate. We've covered a lot of important concepts in this unit. We started by investigating solutions and looking at the way solutes and solvents interact with each other. We performed a lab with solubility curves and learned about important terminology such as unsaturated, saturated, and supersaturated. We examined the various ways the concentration of a solution can be expressed, such as mass percent, molarity, and molality. And our students learned how to create solutions of known concentrations. We even made ice cream to investigate colligative properties and factors that affect how a solution's freezing point and boiling point can be altered by the presence of a solute.
That's not bad.
We learned the fundamentals of how to name acids and bases and how to use a very powerful analytic tool, titration. Finally, we learned how to use molarity to calculate the pH of solutions. If you'd like more practice using titration in a real-world application, go to our Chemistry Matters toolkit for this unit, where you'll find an open-ended investigation you can do yourself. Now, to put these ideas together for you, we spoke to Winston Eason, an agriculture and natural resources agent with the College of Agricultural and Environmental Sciences at the University of Georgia. He specializes in tropical agriculture, animal and poultry science, and agricultural economics. Thank you so much for joining us today.
You're welcome.
Would you start out by telling us a little bit about what it is you do at the University of Georgia?
Okay, so my title is what is termed agricultural extension agent, and basically we share research-based information with the consuming public. So we have researchers, we have research stations, we generate a plethora of information that relates to agriculture. And my job is kind of providing a conduit for the sharing of this information that's generated.
And you also deal with things like fertilizers to enhance the growth.
We do. Fertilizer is typically added back to the soil to improve on the fertility level. We do have some fertilizers that are combinations of a pesticide, in this case, most likely some type of a herbicide that is used to control weeds, whether on the farm or in the residential landscape.
Sort of a weed and feed that we might find at a normal...
Kind of like a weed and feed that you'd normally find at your big box stores and so forth.
Now, you talk about soil testing and you're looking for those different nutrients, but you're also looking at pH levels, is that right?
That's correct. Very big part of the soil analysis or the soil testing is determining what the soil pH is. And the pH is just a measure of the acidity or the alkalinity of the soil. Different pH range within the soil profile. Most of these elements, the nitrogen, phosphorus, or potassium, and some of the other elements, trace elements like aluminum and so forth, all those can be tied up in the soil if the pH is out of range. Knowing what your pH range is can actually determine whether or not you add agricultural lime, which is calcium carbonate, which is used to actually adjust the soil pH and to free up the elements in the soil so that plants can actually uptake these nutrients.
And that agricultural lime, the calcium carbonate, that's going to make it more basic, is that correct?
Right. Right.
Because our soil tends to be a little bit more acidic.
Well, yeah, historically, the soils here in Georgia are slightly acidic, and most plants tend to prefer or function at a slightly acidic range, but there are times when the pH can be extremely low, where we'll necessitate adding that agricultural lime, calcium carbonate, to bring it back up to closer towards 6.5 or so.
We hear a lot these days about conventional crop growth versus organic. And what are some differences that may take place in the different types of growing?
Right. So if we're growing organically, we're making the assumption that we're probably approaching the production process from a more holistic point of view, or what is called a more sustainable point of view. And so there are certain type of chemicals, if you wish, or pesticides that are not allowed in an organic system. So we'll probably use more natural products to control pests, insects and disease and so forth in the soil, or on the farm, or in the backyard garden.
What about, speaking of sustainability, the effects of long-term use of some of these chemicals?
Right. We've had a lot of challenges with long-term use of almost all the pesticides that we use. One of the big challenges that we're facing right now is what is called pests resistant to the different types of herbicides or even the fungicides and so forth that we use. And this comes about just due to long-term use or long-term exposure of the pests to the particular chemical. And over a period of time, of course, the pest develops some type of a resistance. So the chemical doesn't work anymore.
Now, you've touched on this a little bit, the difference between large-scale farming and what most of us may do, our little personal farms.
Yeah.
What are some ways that we can apply what you all do on the large scale in our own homes?
Oh, well, we part of the information that we share from the university point of view addresses a lot of residential type issues. One of the big trends right now is just urban gardens, urban vegetable gardens and beautification projects and so forth. So we can actually scale down a lot of the information that we use for our commercial farmers to fit into an urban situation or maybe into a residential type situation. A very big part of what we do too is just working with homeowners on establishing backyard gardens.
Oh, great.
And it's a kind of a trendy thing now. So we are getting a lot of requests on how to grow your tomatoes or maybe watermelons and so forth in the backyard.
What are some of the most popular crops that people are growing? You mentioned tomatoes and watermelons.
Right. Well, here, from a backyard point of view, tomatoes probably is the number one. Everyone wants to know how to grow the biggest tomatoes.
Got to have your BLTs.
Got to have a BLT. So we share a lot of information on that. And there are lots of different varieties and so forth on the market. But it's a very simple crop to grow. And typically for a backyard situation, if you're not used to growing or not used to the production process, I usually recommend that you start up maybe with containers. And you can start most of your vegetables can be grown in containers until you've kind of gathered enough information to move on to maybe, say, an in-ground garden.
Right, wonderful. Well, it seems like the work you do has so many applications, from the large to the small. Tell us how you got into this work.
Oh, well, actually, I grew up on a farm, basically. We used to actually raise sheep and lots of vegetables. So my background is kind of linked to agriculture to a great extent.
Great. And what sort of pushed you into making this a career? Was there some background in chemistry or some of the other sciences that got you interested in that?
Well, actually, my first exposure to chemistry was, if I can recall, goes back to maybe my first grade teacher, who introduced us to maybe just trying to figure out what vegetables are acidic and which are slightly acidic or more acidic. And we used the old-timey litmus paper to kind of dab around and to figure out which ones were more acidic than the others.
So the seed was planted early.
That's right. Yeah.
Well, thank you so much for joining us. This
You're
is really
most
interesting
welcome.
information.
Thanks for having me.
Appreciate it. Thanks to Winston Eason for joining us here at Chemistry Matters. By now, you should be able to explain from a chemist's perspective several real-life situations with your newfound knowledge of solutions, acids, and bases. For instance, how could we get more sugar to dissolve in our tea? Why do sodas taste better when they're kept cold? Why do antacids make your stomach feel better? Why is it that hydrogen peroxide can be used as a disinfectant at very low concentrations, but would cause burns to human skin at higher concentrations, and can be used as rocket fuel at even greater concentrations? Why does soap work to clean off grease while water alone will not? Why does the presence of salt on our driveways in the winter help keep snow and ice from sticking, but will also make pasta boil at higher temperatures? If you can answer questions like these, you are ready to move on to Unit 8, Thermodynamics. If not, feel free to review any of the material in this unit, and I'll be waiting for you at the top of the first video on the Unit 8 playlist.